Times when we use the quadratic formula and we end up with a square root that we're not able to simplify, and we end up having to plug that value into the calculator to get an approximation for the solution or the solutions to a quadratic equation. What we're going to look at today is how to simplify square roots. And then you can take and you can apply this to when you're solving quadratic equations using the quadratic formula and the answers don't come out nicely. And I'll talk about what that means in a little bit. Now, in order to do this, you got to kind of understand a couple different ideas. And we're going to talk about both of those ideas before we actually go through and do some examples. So let's take a look at this first part, the opener. So the opener reads, determine the prime factorization of the number 180. So 180 is an even number. So it's divisible by 2. So 180 is also equivalent to 2 times 90. 2 is a prime number, 90 is not. So we can continue to factor 90. So that's 2 times 45. Now again, 2 is a prime number, but 45 is not. So 45 is divisible by 5. So that's going to be 5 times 9. So right now we have a 2 times 5 times 9 is the factors of 180. 2, 2, and 5 are prime. 9 is not. So 9 can be broken down to 3 times 3. And at this point, all the factors that we have are prime numbers. So over here, I'm going to rewrite 180 as the product of those factors. So 2 times 2 times 3 times 3 times 5. That product right there is 180. Now, another equivalent form, we can write that factorization is 2 squared times 3 squared times 5. Now, when we're simplifying square roots, being able to find the prime factorization of a number is probably the easiest method. It's not the most efficient method. So I'll show you the easiest method and the most efficient method for simplifying radicals in just a minute. But again, it's going to kind of come back to, or it's definitely going to come back to this idea of prime factorization. All right, so let's quickly look at a property of, in this case, it's just square roots, but this idea applies to all radicals. You look at cube roots in the future, fourth roots, fifth roots, but right now we're going to focus primarily on square roots. So the property is this: the square root of a times b, which is this statement right here, is equivalent to the square root of a times the square root of b, as long as a and b are both greater than or equal to 0. So we're not going to be taking negative square roots in these scenarios. So let's take a look at these expressions. All right, so the directions say simplify each expression. So the square root of 14. What I'm going to do to try and simplify this is I'm going to try to look for perfect square factors of 14. So number that I multiply times itself, that's a factor of 14. If you look back up at 180, 180 has a couple perfect square factors. It has 2 because 2 times 2 is a factor of 180. And then 3 squared is also a factor of 180. So that's kind of what I'm looking for here. So what I'm going to do here is the simplest method, which is doing the prime factorization. So if I do the prime factorization of 14, I get 2 times 7. Now 2 and 7 are both prime numbers. So 14 does not have any perfect square factors, which means the square root of 14 is not going to simplify any further. So this right here, the square root of 14 is simplified as far as it can be. Now you can take a decimal approximation of this if you want to, right? But again, this is simplified as far as it can go. Let's take a look at the square root of 18 and see if that's any different. Now the square root of 18 is even, or excuse me, 18 is even. So we know that's divisible by 2, so we have 2 times 9. 2 is a prime number, 9 is not. So 9 is 3 times 3. So I'm going to rewrite the square root of 18 using the product property. It's going to equal the square root of 3 squared times the square root of 2. Well, the square root of 3 squared is just 3 because squaring a number and then taking the square root. Those are inverse operations, so they undo each other, so we're just left with 3. The square root of 2, 2 is a prime number. It doesn't have any factors besides 2 and 1, so we can't reduce that any further, just like the square root of 14 in problem number 1. So the square root of 18 is equal to 3 times the square root of 2. So this would be the exact value. Again, you could take a decimal approximation of that if you want to. It depends on the scenario. It depends on the directions. Square root of 75. Let's take a look at that one. Now, again, here, I'm going to use the simplest method, which is the prime factorization. And on problem number 4, I'm going to show you what I think is the more efficient method. And once you get better at this, you'll probably choose the method that I'm going to use on number 4 versus what I'm doing right here. So 75, that's divisible by 5. That's 5 times 25. And then 5 is a prime number, 25 is not. 25 is 5 times 5. So I'm going to rewrite the square root of 75 as 5 squared, actually the square root of 5 squared, times the square root of 5. So that's going to equal 5 root 5. So again, I'm looking for any perfect square factors, because if I take the square root of a perfect square, I get a nice rational number instead. All right, square root of 8. So in this scenario, I'm not going to find the prime factorization. What I'm going to do is I'm going to think to myself, do I know of any perfect square factors of 8? Well, 8's divisible by 4, and 4 is a perfect square. So I'm just going to rewrite this as the square root of 4 times the square root of 2. If we multiply 4 times 2, we get 8. So if we multiply the square root of 4 times the square root of 2, we get the square root of 8. Now, the square root of 4 is 2. The square root of 2 cannot be reduced any further, so we can rewrite the square root of 8 as 2 times the square root of 2. So again, we're trying to remove any perfect square factors that we can find from underneath those square roots in order to simplify them as far as we can. All right, we're going to go through a few more examples. The square root of 375. So when I'm looking at the square root of 375, I'm thinking to myself, 25 is a factor of 375. So the square root of 375 can be written as the square root of 25 times the square root of 15. The square root of 25 is a perfect square. It's 5, because 5 times 5 equals 25. The square root of 15, the only factors of the square root of 15 are 5 and 3, and 15 and 1. So 15 doesn't have any perfect square factors, so we can't simplify that any further. So the final answer here would be 5 times the square root of 15. For number 6, we have 5 times the square root of 200. So when I look at 200, I'm thinking that, well, that's divisible by 100, and 100 is a perfect square. So I'm going to rewrite this expression as 5 times the square root of 100 times the square root of 2. 5 I can reduce at this point. The square root of 10, excuse me, the square root of 100 I can, that is equal to 10. And then 5 times 10 is 50. So 5 times the square root of 200 can be reduced down to 50 times the square root of 2. Let's take a look at these last two examples. We have 2/3 times the square root of 27. So when I look at, let's get back down there, 27, say 27 is divisible by 9, and 9 is a perfect square. So we have 2/3 times the square root of 9 times the square root of 3. Square root of 9 is 3, so we get 2/3 times 3 times the square root of 3. 2/3 times 3 is just 2. So this reduces down to 2 root 3. And then the last example, the square root of 40. So when I think about the square root of 40, 40 is divisible by 4, which is a perfect square. So this is going to be 3/5 times the square root of 4 times the square root of 10. The square root of 4 is 2, so we get 3/5 times 2 times the square root of 10. And then 3/5 times 2 is 6/5. Now, again, I always look at my other factors here. So I have the square root of 10, and I think to myself, are there any perfect square factors of 10 that I can take out from underneath that square root? Um, 10 is divisible by 5 and 2, and 10 and 1, and that's it. So 10 does not have any perfect square factors, so we can't simplify that any further. So when you're asked to simplify a square root, all you really need to do is to take out as many perfect square factors by applying the product property of square roots, um, and writing it as a product when you're finished. Okay, so you're going to have a rational number that's outside of the radical, and then an irrational number, which is your radical expression, remaining. Um, Again, you kind of have two different ways that you can approach it. One would be take the prime factorization of the number that's underneath the radical, which is called the radicand. If you do that, you're always going to end up with the correct solution. The other way you can do it is kind of use your number sense and think about, okay, what number can go into this radicand that is a perfect square? All right, and that tends to be the more efficient way of doing things. I hope this video was helpful. You should go try some practice now, which is linked to the doc in Google Classroom. If you have any questions or concerns, feel free to email me or message me through Google Classroom. See you in the next video.